Good morning, grade 11s. So a student asked me a question, and this is what the question reads. A block is pulled at a constant speed on a rough horizontal surface. The block is pulled with a force of 45 Newton at an angle of 55 degrees. So which means over here we have an angle of 55 degrees to the horizontal. Okay, fine. Now let's try and understand what the question says before we start answering the questions, right? A block is pulled at a constant speed. We know that once we see the terms constant speed, it means what? It means that there's no acceleration, right? Okay. On a rough horizontal surface, what does it indicate? It indicates the presence of frictional force. Okay, and the box is pulled with a force of 45, which has been indicated over here at an angle of 55 degrees to the horizontal. Okay, so question number 1, they're asking us to draw what? The free body diagram. Number 1. They're asking us to draw the free body diagram. Remember that the free body diagram, it's represented by what? By a dot. Okay, so after drawing your dot, you then have to draw all the forces where on this, acting on this object. So we know that if something is on a straight surface, what we will have a normal force acting perpendicular to the surface, meaning acting at the 90 degrees angle, right, to the surface. So here is our what? Here is our Fn, which is our normal force. Sorry. And then we know that we have weight, which is pulling down the object to the center of the earth, which is gravity, right? Let's just draw it over here as well. And then we have F applied. This is Fg. We have F applied, but look at this force applied. One thing that students normally do when they're drawing the free body diagram, which is incorrect, they'll try and break this force into its component, into its y component and its x component, and redraw it over here in its component form, which is very incorrect. When you're drawing the free body diagram and you're given a force applied like this, we instruct students to take it directly as it is, then draw it over here. Don't break it down into its fx component and its fy component. It's going to be incorrect. Then because it's acting at an angle, it's not directly straight, we will put it down at an angle. So this will be 45 degrees Newton, right? Okay, now, and we also have frictional force, because remember they said what? It is on a rough surface. So we have frictional force acting in the opposite direction of the applied force, because if the applied force is this side, then it means that the frictional force will be where? This side. So this is your Fk. Okay, number 2, question 2 is saying magnitude of the frictional force. Now let's go to number 2. Just keep this here. Let's go to number 2. So now they want to know what is the magnitude of the frictional force. But before that, let's go back here. They're saying that a block is pulled at a constant speed, right? Which means we have no accelerations, which means that in the y directions, what? In the vertical directions, all the forces here, they're equals to 0. Bear that in mind, right? So now, wait, before even that, let's break down our, because we're calculating for the magnitude of the frictional force, we can now break down this force into what? Into its components. So it's going to look like this. Wait, we have our Fn, we have our Fg, we have Fk, this, it's going to be the x component of this force over here. So it's going to be F cos theta, sorry, which will just be what? 45 degrees multiplied by cos of 55 degrees, right? And then we are going to have another force, a component force of this applied force going upward, which will be I think let me write it like this. It will be Fy sine theta, which will then be 45, sorry, sine of theta, sine of 55 degrees, right? So now you have your x component, you have your y component of the 45-degree Newton, right? So now, just by looking at the diagram, you can see that the frictional force, it's equals to what? It's equals to the x component of the 45-degree Newton, because the frictional force and the x component of the 45 Newton force, they balance one another out. Understand? So which means Fk, it's just going to be equals to the x component of the force applied, just that in the opposite direction, right? Because if we're taking our right as positive, it means that this x component, it's in the positive direction because it's moving to the right, and then this Fk, because it's in the opposite direction, which is the left, it is moving to the left, then it will be negative, right? So Fk will be equals to F dot cos of 55. I hope you guys get what I mean by that. Then this will be 45 degrees multiplied by cos 55. Now let me just punch this in the calculator. Let me see what it is. 45 cos 55. It'll be 25,81 Fk will be equals to 25,81 Newton, right? Okay, now for number 3, they're saying calculate the magnitude of the normal force. The normal force, it's this force over here, right? It's this force over here. Okay, again, let me, just for convenience sake, let me just draw, just because Fn, it's in the y axis, let me just draw all the forces acting in the y axis, right? So we have these two, and then we also have weight. So this one, it will be our Fn, which is our normal force, which is the force acting perpendicular to the surface, right? Then this one, it will be our y component of the 45-degree Newton. So this will be F multiplied by sine theta. Sorry. And this will just be m dot g. And because they told us that a block is being pulled at a constant speed, it means that there's no acceleration. Remember what I was saying, that if they're telling us that there's no acceleration, it means that the forces in the y-axis, they will equate to what? To 0. So if you're trying to find our Fn, right? Remember here, in this case, we're taking up as positive. Remember, you need to give direction to what you're doing so that when you're adding up things, they make sense, even to you, right? Okay, fine. So we're taking up as positive. Remember that the forces in the y direction, in the y-axis, they're what? They're equals to 0, right? So we're going to have Fn, which is our normal force, plus this F sine theta, because they're acting in the same direction, right? And we're trying to find Fn, remember that. It will be F multiplied by sine of theta minus m dot g. Why is it a minus m dot g? It's a minus m dot g because weight, it's acting in the downward force, right? It's pulling the object towards the center of the earth, equals to 0. So you're going to say Fn equals to, transpose this F sine theta to the other side, it will be negative F multiplied by sine theta. Transpose this mg to the other side, because we're trying to make Fn, which is our normal force, the subject of the formula, hence we're transferring, right? So when we transfer this term to the other side, it will be positive m dot g. Do we have the mass of the object? Wait, yes, this is 6 kilograms, sorry. So for our Fn, we're going to have it as negative, what is our F? 45. What is our angle? 55 degrees. Plus, what is our mass? Our mass is 6. What is G? 9,8. It's a constant, right? Now let me put this into our calculator to find our Fn. Let me say Fn. No, yeah, our normal force, which will be equals to. Let me just put that in the calculator. Our normal force will be equals to 21,94 Newton. Does everybody understand this? Please, you can either say in the comments or tell me in the group if you don't get this. Anything.